final part of these notes for activity 1 is going to move on from just talking about one singular term and what happens instead when we want to sum up our sequence a certain number of terms. Think our pal sigma from earlier in the activity. So what we want to do is sum up a certain number of terms. So we call this S sub n. And S sub n again stands for the sum of n number of terms. And again, n is the number of terms we are adding or summing together. And then a sub 1 is the first term value that we are going to add. So that number in the sequence. And then the nth term is the last term value of however many n terms we are adding, whatever that term is. Okay, so a lot of times you are going to want both of these handy, both this explicit formula that we talked about and the summation one for finding these, because sometimes we need the explicit in order to find the term number. So in these last two examples, in example 10, notice we have a sequence where we are adding 4 each time as our common difference. Our first term is 3, our 40th term is 159, and we want to write the sigma notation for this, and we want to find the sum of the first 40 terms. Well, remember with our sigma, we start at term number 1, which is 3. Term number 1, which is 3. Oh my gosh, too much. Term 1, which is 3. And we are adding up, it says, the first 40 terms. Now, the thing is, we need the rule for those first 40 terms as well to complete the sigma notation. So that's where our pal, the explicit formula, comes in, because we know we can take that first term and we can take that common difference of 4 and then keep n minus 1. And it's going to allow us to find our rule, which in this case, we combine like terms, is 4n minus 1. So this is our rule for our sequence, and this would be what this in sigma notation looks like. Now, if we want to find the sum of the first 40 terms, what we can do then is take those first 40 terms, divide by 2, so n divided by 2, our formula, and then we need our first term value, which is 3, and then that 40th term value, which they told us is 159, and we can sum those together to find this. So n divided by 2, first term value of 3, plus the nth term, the 40th term value of 159, gives us a total of 3,240 as our total sum value of all those terms. Now on our next example, this time they are telling us the first term in our sequence is 14. So there's our first term, a sub 1, and it increases each time by 10. So that's our common difference value, and we want to sum up this time the first 16 terms. So again, when we start talking about our sigma notation, we start with term number 1, and we are ending with term number 16 this time, and we need our rule. So again, we're going to kind of have to sidestep here and figure out what that rule is using the explicit formula. So first term is 14, increasing by 10 each time. So we have 14 plus 10 times n minus 10 after we distribute. And if we combine 14 minus 10, would be 10n plus 4 is our rule. The 16th term then is going to be found by using that rule as well, because remember, we can use the explicit formula then to help us find. So we know we are looking for term number 16, aka this n is 16 now. And we would be able then to find that term would be 164. And then last but not least, For summing up then the first 16 terms, again, we have our n divided by 2. First term is 14. 16th term is 164. So again, if we take 16 divided by 2, first term we said is 14. 16th term is 164. We get our total of 1,424. Now, something that's kind of interesting about these as well is officially, those of you with a newer calculator, you can do this in your calculator as well using your sigma. So what we could do is if you take alpha window and scroll down to option 2, your summation, you can type in these values. So for instance, for our first example up above here with 40 terms, instead of using n, you're just going to use x, start at 1, go up to 40, and then type in that rule that we had for x minus 1. And we see that that sum was 3,240. So it does the same thing as our formula there. Same idea with the one down here. If we do alpha window, option 2, start at term 1 this time, going this second example to term 16, our rule was 10n plus 4. Again, we're just going to use an x for the sake of the calculator. Hit enter, and we get that sum as well. So it gives us some options then, if we have a calculator that possesses the ability to do this, to find that formula. Thanks everyone for watching. We'll work more with these in class.